Hello and welcome to a math video. For some reason today I'm speaking in English. Sorry for the accent and the mistakes. Today we are going to make circles and spheres with cubes. To do so, to create spheres with cubes, we need to find the coordinates at which we would put the cubes. And to do so, we are going to use Pythagoras' theorem. If you remember, Pythagoras' theorem is basically the square of the hypotenuse is equal to the square of the base plus the square of the height. Well, we can see that in a circle, the hypotenuse is the radius and it stays constant. It's always the same. So if I take this distance, x, the red one, x squared, red x squared plus y x squared is equal to r squared, and green x squared plus y x squared is also equal to r squared. So that's a function that I can make. If I solve for y, I get y is equal to square root of r squared minus x squared, and I turn that into a function magically, replacing y with f of x. In order to understand this, we have to imagine that a sphere is just a collection of circles that get smaller and smaller the further away you go from the origin. So I'm going to use my function to calculate the y-coordinate of my blocks with respect to x. But once I do that, not only do I get the y-coordinate on the big circle, but I also get the radius of a smaller circle, and I can use that radius to create a new function that is exactly the same one as the first one, only with a different radius, the radius of the smaller circle, and this time with respect to the z-axis, the z-coordinates. And that will give me the y-coordinates of the block with respect to not only x but also z, so it will give me the coordinate of that blocks in this area, and I can repeat that for many circles, and I will have the coordinates of all the blocks with respect to x and z. And when I will put this function in my spreadsheet, basically this will look like this. So I will have a first line with my function with the original radius, the radius of the sphere. And then on this column, I will also have the same function with the same radius of the sphere. And for the rest of the spreadsheet, the radius will change for each column. So this is the first circle, then a second circle, then a third circle, fourth circle, and so forth until the end. And that will give me a complete sphere. Now, if I repeat this pattern, as we just did, we will get an eighth of a sphere. If we want a full sphere, we need to repeat this pattern 4 times from the bottom up, and then 4 other times on top. One thing, though, on which I want to insist is these little areas that I overlined with rectangles here. These are the origins, so it's always a good idea to start by building these, placing these cubes, before doing the rest, because once we have set that up, you just have to go next to this one, and 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 repeat the pattern, and that will make it actually easier to keep track of which blocks we put. So this means that this is not really complex, but it can be cumbersome. So basically what I do is I start from 20, thinking that my origin is the center of the sphere, a little bit up there. I start at 20 and I count 1, 2, 3, 4 blocks on the 20 line, and then I add a little block to stick, and I go 1, 2, 3. There are 3 19s, and then 1, 2, there are 2 18s, and then 1, 2, there are 2 17s, and so forth. We just need to follow this spreadsheet in order to know where to place all these cubes. Fortunately, we don't need to use the entire spreadsheet. Only an eighth of it is actually really useful. Well, only an eighth of all the coordinates are actually really useful. Because look at this. If I start at 16, I would go 3 cubes here, 3 cubes here, 1 cube here, 1 cube here. But it's the same thing if I start from this side, 3 cubes here, 3 cubes here, 1 cube here, 1 cube here. So that will be a little bit easier to repeat the pattern when we are going to do the entire sphere. So here is my spreadsheet. Basically, I have my formulas. I set up my axis. So there's the x-axis going from 0 to 100, and the z-axis going from 0 to 100, and the radius of the sphere, which will be 100 cubes. So basically what I'm going to do to calculate the y values, where I will put the blocks starting from the ground, starting from the 0, I just need to enter my function. So my function is square root, if you want to know, in French we say racine, square root of the radius squared minus the x value, so this one, squared as well. Now we have to make sure that the spreadsheet will always go into that cell to get the value for the radius. So we are going to put a little dollar sign before the A. So here's the dollar sign. And why before the A? Because this is how it tells the spreadsheet to always go to this value when we repeat the formula horizontally. So I'm going to go up to 100. Where is 100? 100 should be here. Yeah, here's 100. Now we are going to take care of the z-axis, so we are going to use the same function, but this time the radius is on this line, and it changes every time we go from column to column. So square root of this number squared minus, this time we are along the z-axis, that number squared. Now we have to be careful with one thing, is that if we are going to copy this formula, this is going to not go necessarily where we want it to go to get the values. So here we want it to go always on this line, but every time we copy to the right from column to column, we want it to go to the next one. So in order to do so horizontally, we put the dollar sign between the D and the 7. But we also want it to go look when it goes across this line for the Z value always at the same column. So this time we're going to put a dollar sign before the coordinate of the Z value. And now what's good about this is that if I copy it down, it will always go in this cell to get the radius. And if I copy this whole thing in that direction, it changed the coordinate for the radius, but it kept the coordinate for the Z value. So the beauty of it is that now I can take this thing and I can copy it down to 100, and I can copy it to the right to 100. My problem is that I don't know where 100 is here. And oh, almost there, getting closer, really closer, and here I am. Now I have successfully programmed the entire spreadsheet. So you will notice that I made it such that all the numbers are whole values, because I'm going to put entire cubes to make this sphere. So it's important to set up your spreadsheet so that it does this. Usually it's in the format of the cells. And you will notice also that here things get a bit wonky towards the end. We have this error 502. It's basically because it's trying to take values that makes a negative inside the square root, and the spreadsheet doesn't like negative inside a square root. To it doesn't make any sense. It's actually an imaginary number, but that's a question for another course in mathematics. But why do I want to do a sphere with cubes in the first place? And why did I bother to do a spreadsheet in order to do that?
So welcome to yet another Minecraft video. Today we are going to build a sphere in Minecraft using cubes. So here's a little platform that I made, and I placed red blocks here so that would be my origin. So the red blocks are the origin. I'm just going to do a simple sphere of a radius of 20 blocks. So I have my spreadsheet, and with that spreadsheet I can follow the directions. I'm going to put 1, 2, 3, 4 blocks here, then 1, 2, 3 blocks here, and then 1, 2 blocks here, and then 1, 2 blocks here, and then 1 block here, and then 1 block here. Okay, you guessed it, with my Minecraft skills, this is going to take a while, so let's speed it up a little. So I have arrived at the end of my spreadsheet, so I put one last block to signify that it's my origin, the zero level, the zero line. And then I'm asking myself, how am I going to do the rest of the sphere? Well, I go from the end of the spreadsheet backwards, so I'm going to add 6 blocks here, and so forth. Then up to 9, to 11, to 12, to 13, etc. Now I have a nice semicircle, 14 blocks high. That's good. And what I need to do is do it again, 3 more times. Doing so is important, I think, because it allows us to catch any mistakes that we may have done early on and not have to do the entire thing again. If you go too high or not high enough, you know that you made a mistake, you can do a half a circle again. But it looks like we are done with the time lapse, so let's go back at it. So now we have the nice structure for our sphere. What is all left to be done is, well, fill that up. But we've seen that it's not that difficult. We just need to follow the spreadsheet, only we are going to the next line. So using the next line, we are going to go in this direction, and then in this direction, then in that direction, finally in that direction. So all that there is left to do is to just do it, fill up those lines. I should have some file with some catchy music, more or less, somewhere. So let's go on with the time lapse. I don't know how professional YouTubers do it, but I'm running out of things to say. So here it is, our completed sphere, 20 blocks radius. So obviously it's not perfect, it's made in blocks, and you can manually remove some things that you may not like this little block here, it looks weird. But obviously it's one of these things where bigger is better. The bigger the sphere, the more the resolution will be precise and better, and the more it will look like a sphere. Like, for example, that thing. I only made half of it, but it's the first part of a sphere with 100 blocks of radius. I added some cute things like circles for the entrance and stuff like that. But that's the idea. With this spreadsheet, you can basically make any type of sphere you want. And if you want for it to be more than 100 blocks in radius, you just have to make the spreadsheet bigger. Thank you for watching. And if you want more math videos with a French teacher, please feel free to subscribe. And I think that's it.